Okay, so this week we're going to talk a little bit about functions, but before we start, I want to share with the students in this class, if you want to join an organization that always going to look good on your resume, especially for computer science or the technical area, this website is I don't know if you're familiar with Anita B, but Anita B, she created a lot of she developed a lot of tools and technology in the computer science area. And you have opportunity to join the membership for free. There is an option for you to become a premium member. But every year they host a huge event, and as a member, you can participate in the event. Like they'll cover some of the costs for you to come to the conference. You are also being mentored by professionals in the field, especially for female students. And then you'll be able to access their career center. And you can use the website. You can go to anitab.org and you can sign up for the free membership. With that, you'll be able to access resources on the website, which is pretty cool. They reached out to me a while back. Long ago, at the end of COVID, I participated as a mentor in the group, right? I haven't been because my schedule has been kind of busy, but this is a good option if you want to sign up. So I just want to share that. So anitab.org. Okay, and today we're going to talk about functions. Mr. McQueen doesn't have Unit 6, 7, or 8 created in the Canvas, so I built out the module so you can find the module information after Unit 5. I know that there's some programming challenges that he assigned, so if you want to work on that this week and next week, it's not due until right before Thanksgiving. I'll take a look at the second midterm or the second test and see what kind of information that is required for the exam. And then maybe we can talk a little bit more about it when we meet again next week. So this week we're going to focus on functions. This is important because in the future classes, let's say that if you're taking other programming classes like 17A or CIS-7, discrete structure, you would need to know the basics. And it's going to help you proceed, especially if you are in the computer science area. So I tried to put everything on one document so that way you don't have to go back and forth, right? So in this week, we are gonna create our own function. So far, we've been using main, and that's okay. But a lot of the times you want to have a modular design in your application. So over time, you can maintain just that piece. So for example, I might have a function to calculate tax on the receipt. And as you know, tax would change in different part of the country or state. Also, tax will also change depending on, inflation or whatnot, right? The political parties. So what we can do is we can just modify that particular function instead of the entire program. But if you made it into main, what will happen is the system is going to rely specifically just for main function to execute everything. And if your program is very long, it's going to take a long time. So it won't be efficient and fast. So the main purpose of using a function is that you're able to recall the function continuously. So let's say that you write a function, you're able to reuse that function for other purposes. Like I might have a function to greet customer, like welcome to my app. And I want to be able to incorporate that into a loop so I can just keep looping down the line. So what I can do is I can just use that function and it's already created, so I can just recall that function over and over again. It's also going to allow you to break your program into smaller chunks. Keep in mind that every component that you put into a C++ program right? Like a variable, a container. We talked about how that's typed. Your function is typed also, right? It basically cut a portion of your computer memory and it creates that section for that function. So in your function, you might have variables, like more than one variable. It's going to load the variable into that region of your RAM or your memory. And then after the function is executed, it's then going to flush that out and be able to reuse the actual memory location for other things. So it is a way that we can specifically organize our program and we can manage the parts like I mentioned, right? In modular approach, it is a lot easier if you chunk your program into pieces. Over time, you will find that your application is going to be easier to manage if your application is big. For example, if you're making a game, you want to be able to have function for things like selecting weapons or be able to select characters, right? And so that way, over time, you can change the content of it where you can add new characters to it without modifying the entire program. So it's definitely useful. And then when someone else or yourself is fixing your program, it's a lot easier to go through and fix the error specifically for that area. Versus if you have the entire program, it's probably harder to go through line by line, right? If you have 1,000 lines that in the main function, it's a lot more difficult and it's time consuming. So what we can do is we can also divide up our task in a team. Maybe multiple people would write different functions and then incorporate that into a program. So that way it is easier to build. So that's some of the benefits in using functions, right? In every programming language, you're going to see that function is used for these main reasons. So you have seen some of the math library functions, like we've used ceil and floor to round numbers or round itself. Those are pre-made functions from other programmers' files, right? Those are from the library, the standard library in C++. You also use cout and cin. That is also a function that's pre-built. Okay, so that way we would just bring in the library and be able to incorporate that into our program without having to reinvent the wheel. But today you are going to create your own function, and that's called the user-defined function, where you can custom your own function. You can have as many as you want or as many as your memory is allowed, usually, right? The computer, it does have a limit in the stack. So whenever that you have a function, it loads it to that region of memory, and there is a cap. So there's not a system that has unlimited resource, right? That there's no such thing. Every computer, even if you're looking at a supercomputer, or even a computer that generates AI results, right? Or query, what you see is that there is a limit in the resource that it's using. So when we write a function, just like how we define a variable, because C++ is a strongly typed language, you have to give it a type, like int for integer. So if your function is going to handle whole numbers, right, then we want to type that as int. If it's handling decimal or very large number, we can type that as double. Right? If it's your function is recording user input one character at a time. So in my Python class, I usually give them a project to do a keylogger. I don't know if you're familiar with the keylogger. So it activates the keyboard, waiting for the user to strike a keyboard. It capture, let's say you type your password, it would capture one character at a time and it streams it into a variable or an array. And then an attacker can use that to fish out your password by bringing that information into their own system. So in that case, I would have to use char if I'm writing it in C++, right? Because it's streaming per character. But you can also use string if you're recording like words or sentences, right? So in the format, we want to make sure that we type our function, and you can identify or name your function whatever you want, right? in your program, you have the flexibility in writing your own function name, but we want this to be relevant, just like how we use it for the variable, and making sure that it really means what it's supposed to do. What is your function is intended to do? What's the intention of your function, right? So if I want a function to greet customer, I can say, string, right? Greet customer, that will be my function, right? You can use upper lowercase and underscore to kind of write the name that's easy to read. Now we are going to do the programs that we're going to pass the parameter. So whatever that you put in the parentheses could be variables, right? Or an actual value. Normally we pass the variable that contains value into the parameter here. And so if I have int x as a variable and x is equal to 5, it's going to then plug in, and we're going to talk about reference variable and regular passing the value with the normal variable. So you want to put that in the parentheses. And if you have more than one parameter, you're going to use a separator, which in C++ is a comma, like many languages. Okay, so you can have as many variables or parameters as you need inside your inside whatever that you need here for your function. And then C++ require that you have the curly brace before the body of your function. So most of the time we're going to do cout or cin inside here, right? Like you might have a function to record user input. So your cin would be executed here. Now, in order to run your function, main is a function that calls the rest. So think of it like the leader function. It cannot execute without main, okay? The way the compiler is created, that main calls all functions. It's kind of like that's the leader. Without main, you cannot call function. In Python, there is a main, it's just hidden. You don't have to type out like the main function to call the rest. You just call the function at the end. So normally we would want the call to be inside the main function body or near the end of it. So that way it can execute, right? It won't execute without main. So main will call all the other functions, okay? In the next week, I'll talk about prototyping functions on how we can place a function into a specific area of our program so that way the compiler knows that those are the function we're using. Okay, so we're going to define some functions. So keep in mind that here are the components. You can return value from the function. Most of the time, that is the reason why we write a function, right? So let's say that we want to do a function to calculate the total. We want to return the total at the end of that function. And making sure that we are using unique function name. You do not want to have conflict in name. So if you have two separate functions, they have two different names, okay? Parameters, we talked about that. That will be the values or what you want to be the function to use. Numbers, right? String, the input for your function. And then we can have a return statement. So in many languages, we want to return, right? So you would use the return as a keyword. And that is going to send the result back to the caller. So so in my discrete class, I always talk about using a function to return and use that value in the next function. And this is what you see, right? Like if you're looking at a game, you can return score for every strike that you hit or, every ball that hits the goal. So that function is going to return the score and it's going to take that score and pass it into another function so that way you can convert that score into coins or whatever you want, right? So you can have a return value and use it in the next function and call that function. So it's going to pass that value to the next part of your program. And that's the goal, is to make sure that you chunk it. And so that way we don't lose the value within the actual program if you're having too many things buried within, right? So here it gives you like the overall summary of the components of your function. Now, if you're looking at the example 1 in our programming exercise for unit 6. What we're doing here is we are going to make two functions. One is going to add the numbers, and two, the second function is just going to subtract the number. And it's simple, right? And you are going to use the main to call the function that you create. And that's the practice, right? We have to keep in mind that main calls the rest of the functions. So in this program, you see that you have IOStream just like all the others because we're using cin and cout, and that's a built-in function using namespace std. What we're gonna do here is we create a function called add, right? You can call it sum, you can call it add. Now, be careful about the way you name your function. In some languages, it has those keywords are used as, like in Python, sum is actually a function itself, right? So you want to use something that's unique, that the system doesn't get confused with built-in function or other things that is meaningful to it. So we're going to call this function add. It's not related to any keyword in any libraries that we have in the program. And we're going to have two variables as parameter, X and Y, right? So you can just put in the parameter and use a comma to separate them. Use a curly brace to begin the body of your function. And we're going to return X plus Y, right? Whatever that's in X and whatever that's in Y, it's going to add those values together. Then we have a subtract function. We do the same thing. Our parameter for the second function is X and Y. And we're going to return X minus Y. And just like all the statement, when you do a return statement, end it with the semicolon. So if you wanted to multiply, you can have a function to do multiply, and then you just return X times Y, right? And then at the end of your program, you're going to have the main function. Remember, I said that main is the leader function. It uses main to call the others, right? And inside the main, we're going to have int A and int B. These are another set of variables that we use inside the main. And we're gonna have a display enter the two numbers, so that way the user would know that they are required to input two numbers. And we want to show what they or record the value that they input. And then at the end, when we do cout, we would say the total or the sum, and we simply call the function. So what makes it different than your variable is that it has a parentheses, right? And inside the parentheses, we would pass variable A and B. And then the cout, right? The difference, it's going to subtract A and B. So in this case, what you see is you can use the same variable, but typically inside your main, you are going to use different variable name, and because you don't want the system to be confused of the variable that it needs to pass. So you're going to have X and Y. So these int X and Y, they're just like placeholder. Okay, think of it like the system knows that that's a container. It's a placeholder to be able to plug in, right, whatever that's A or B. So X is a placeholder for A, and Y is a placeholder for B. And this is the common practice, right? A lot of the developer, what they do is they would use different variable inside the user-defined function or your custom function. And then in the main, you would have a different variable. But the variables that you define in your function, those are just placeholders for what will be in the main. Now, if you want to initialize the value and not have the user to input, right, you would need to say what is the value for A and B inside your main, okay? So I know it looks confusing, but keep in mind that whatever that's in main, it's going to plug that inside the parameter. But X and Y up here, it's just a placeholder for the parameter for our own function, and it's going to operate the addition, right, by plugging in A and B for X and Y. Okay, so typically it just cuts portion of the memory and prepare that, right? And then it's going to pass the value. It's going to initialize the value as you type that in as a user, and then bring that into the function. So it's associated by memory addresses. Okay. All right, let me go to my online compiler real quick. And you can copy and paste this into your IDE and be able to run it. Okay, so here's the addition and subtraction that you see, right? When you run this, it's going to ask me for two numbers. So let's say if I put in 4, press enter, and then put in 6, press enter, right? So it's going to take 6, right? And pass it into the place of A. And then, I'm sorry, 4 that pass it into the place of A, and then 6 pass into the place of B. And 4 plus 6 is going to give me 10, and 4 minus 6 is going to give me -2. Okay, so that's how it works. Now, what we're going to do is we are going to do something similar but more practical in our daily life, right? I try to use it so that way you can flourish it out and build an app with it. So we're going to write a C++ program. We're going to create functions to be able to prompt the user to enter their weekly expense. And we know that there are 4 weeks in a month. And we want to use the input weekly expense and create a function to calculate the monthly expense, right? And the yearly expense. Okay. So simply we're going to take the expense, times it by 4 to get the monthly expense, and then times the monthly expense by 12. So this one, you're going to return from each function and then apply the value for the next function. Okay. Okay. So are we clear with the requirement? Any question? Okay, so let's take a look. And you don't have to do exactly what I do. I'm only giving you like demonstrations so that way, if you are new at this, you can have a point of reference. Okay, I'm going to increase the size a tiny bit so you can see. So at the top, we're going to do include IO stream typically for our C in C out. Using namespace std. We're not using another library in this case. So I have the first function, it's going to prompt the user to input their weekly expense. And as you can see on line 13, I type it as a double because some people, their weekly expense might be $60,000, right? For if they have to spend on a lot of different things. And some people, their weekly expense might be a few $100s. So we can't be sure. So we basically cut a container in the memory storage to be able to accommodate large or small values, right? So, and we, in C++ or the practice in C, is that you want to use get and set. So if you're obtaining value, typically you would use the term get. So in this case, I'm going to ask the user, I'm going to get, right, the input from the user for their weekly expense. So I name it get weekly expense. And inside it, I have a variable, right? You notice the difference between a function and a variable. The function has the parentheses where the variable doesn't. So, so I name my variable weekly expense. That's where I'm going to store the value that they input. And I want to prompt the user, enter your total weekly expense, and we put the $ in the front to indicate it's money. Make sure that you put it in quotation mark because it is a string that we're prompting to the user. And then on the next line, we're going to have a CIN to record their input into the variable weekly expense. And we're going to return it. So as soon as they type in, let's say, $1,200 per week, it's going to return that value. We're going to use that in the next function. So you want to do a return statement, and whatever that's inputted into weekly expense, it's going to return that value. And return gives us the output, right? So we're going to output that and use that output as an input in the next function. Then next, so make sure that we close out that function body, right? So think of it like a task that it has to do. And when you complete that task, to ask the user to enter their weekly expense, we want to close out that task by ending that with the closing curly brace. And then now, since we have the value, we're going to calculate the monthly expense. So we have a second function to calculate the monthly expense. And again, I'm going to use the double type. Remember, you have to type your function. And we're going to, I name my function calculate monthly. And then I'm going to pass the parameter. It's going to be the variable, right, that I had used in the last one because it's returned from the previous function. So I'm going to use double weekly expense, right? Whatever that was the input for the expense, it's going to bring it into the next function. It's going to use that as an input to calculate for the next function. And from that, I'm just going to return weekly expense times 4 because there are 4 weeks in a month, right? Simple. And that task is complete. I would close my curly brace. So we want to output the monthly expense and use that again for the next function. And you would repeat similar to the previous function. We would take the monthly function, the monthly expense that was returned and multiply that by 12 so we can get the annual expense, the yearly expense. So if you do a personal finance tracking, right, you can see that you can use individual functions, right, and return from it and then tie that as input into the next function. And so we can continue to call. So your call will be the order, right, how you want that to be calculated. So here, when you're writing your function like this, that's what we call declaring or defining your function. So you have to kind of specify what kind of task it's doing, right? So you declaring your function or you defining your function. And then for the calculation for the yearly expense, I simply have another function called calculate yearly. And again, that's a type double because we want to be able to handle larger numbers, right? And I'm going to pass the monthly expense. Why not the weekly expense? You can, but you have to change the equation, the how you operate the math here. So it's easier because we return the monthly expense. So we want to be able to calculate from the monthly expense and multiply that by 12, right? So here I have a double monthly expense. And I'm going to return the monthly expense, multiply that by 12. And again, right, we open the curly brace for the task that it's doing. So here it's calculating by multiplying by 12. When it's done, we're going to close out our curly brace. So after we define our functions, then we're gonna specify on how we want the main to call these functions. Okay. So next will be your int main, which is your main function, right? Main is the leader of all functions. So we want to be able to incorporate the function that we had declared, and we want to be able to bring that into the main. And you don't have to do the aesthetic port, right? So I just have personal expense calculator, so that way it shows when my app is running. And when we do a weekly expense, so I would have a variable called double weekly. Okay. And I'm going to call the function get weekly expense. So at that point, it's going to bring down the return value from the weekly expense that the user has entered. I'll slow down a little bit. This one is a little bit longer. And then we would repeat the same type of task for our monthly and yearly. So I would have a variable called monthly. And again, it's type double. And at this point, we would call the function calculate monthly, and we would pass the value weekly in there, in the parameter. And for line 38, which is for the next call, we would do another variable called yearly. And we would then say that yearly is, right? We would call the next function, which is calculate yearly, and we would pass the monthly value as its parameter. So you have 3 calls, right, for 3 functions. So as you define your function, if you define 10 functions, you need to call 10 functions in the main. Now, the order that we call the function is how we want the order of the program to flow. Sometimes you see developer, they would have different calls in different order, even though it's defined like 1 through 10, but they might call specific function before. Ideally, you want it in the order that's defined so that way it's easier to debug, but sometimes you might call or recall function multiple times. So in the main, we always want to call the function that we previously defined, okay? Main calls all functions. And you notice that the variable that we previously used don't get passed in the main. Remember what I said, right? They are different, they are named differently. They're just placeholder for the variables that are being passed inside the main. Okay. And then we want to display the results. So this is also part of main. You are going to show, we're going to do a cout, expense summary, and we want to be able to see out weekly expense, put weekly information there, so it's good. So once we return the weekly, after we call that function, it's gonna bring that here to display. And then again, the monthly. And then you can continue to the next line with the yearly as well. So let me see if I can stretch this down so you can see. Now notice the difference between the weekly, the monthly, and the yearly. The weekly doesn't have any parameter, and it's okay that you can do it that way, right? Because for that function, we're only gonna prompt the user for input and output. So we're gonna prompt for output and then using input for the cin. So you do see some function that doesn't have the parameter when you call it. So you don't have to pass the variable into the parameter like what you've seen in the next two function. Only if you want to use that value inside the function that you're calling, right? So if you want to be able to apply the value for the next function, that's the whatever that you put in the parenthesis, it's going to apply the value there. And you can have more than one parameter. So in the case if you're working with like larger data sets, you might have to pull like, 10 values. Then if you're not using an array, then you have to be able to put them into some kind of variable. And you don't have to put thank you for using the expense calculator, but I did. And I had put return 0 at the end. So you can also end that there and put return 0. Make sure that we close out the main function body by doing a curly brace there. But any question regarding exercise 1? We're only going to do 4 typically, right? So from this exercise, you've learned how to be able to pass a variable into a function, return from a function, right? Take that return value and use it in the next function as an input. So you can have as many functions as you need for your application. When you create a function, like I said, it's going to create a section of memory for your function. The compiler does that before it runs. So that's why we type it So it cuts up a container and it would place all the variable that you use inside the body of the function into that space. And that space is typically, we call that a stack. So that's a region of memory inside the computer that's used by the compiler for information and data that it would apply to the program. Once it executed, when it hits return 0, right? When it sees that after it all the function have been called and produced the value or returned value and applied to the next function and so on, when it hits return 0, it clear out that stack space and be able, so it flushes it so that way it can use it for the next program or the next set of code that you run. So on Thursday, I will probably show you how you can write encryption a little bit in your small program. It's going to be a small one. And be able to write functions to do some simple encryption. That's just like a way that we change up your regular text into something that's not plain, right? By applying an algorithm. So you can create a specific algorithm. There are only a few unbreakable algorithms for encryption, right? Usually if you have a powerful system, if you run it over time, you should be able to calculate or find what that algorithm can produce. So nowadays you have very powerful computer and also AI to be able to do that. So what you see is a lot of the cryptography is now being judged based on, you know, how easy or hard it is to break. Any question? Did you miss anything at the top or? Okay, so you can run the program and see if you're able to have weekly, monthly expense and yearly expense uh, specify as output in your program. So if we want to flesh out this program for like finance, personal finance tracking, you can also, we did a program in the past where we have saving information, right? So you can also prompt the user. So you can have a function to ask the user how much money do they want to save and how much money do they make. And then you would be able to calculate like, will their expense meet whatever that they make, right? How will they be able to save? And then you can also predict how much money they can save in a year, 3 years, and 5 years, right? So you see this with a lot of the financial app or even the banking app that you're using. Yes. Okay, I'll come and take a look. always for the function you want curly brace. Yeah, that's a C++ requirement. Okay, any other questions? So for each of the function, the body of the function, we want to wrap that inside the curly brace. Only the parameter we're going to use the parentheses. So in Python, in Java, in C++, right, function uses parentheses. That's how you can distinguish between a declared function and a declared variable. Variable doesn't have that parentheses, right? Whenever that you see the parentheses next to the function name, you know that in Java, they call that a method, right? Also in Python, but because method consists of task, it's just, you know, you would have it flow in how you want your program to execute. And notice in the main, right, we call them in order. We call weekly, monthly, yearly, and that is just a logical way. But you know, you don't define a function and not calling it, because that's just a waste of space in your memory. So, but sometimes you would see that you can repeatedly call a function, right? If you want it to execute again, or you can change up the order, but you want to, it's easier to debug if you declare in order and call it in order, but sometimes there are exceptions in how you want to call your function. Now, in other languages, you would see that sometimes they would be able to apply, like compiler. This is a pseudo program. That means that it's going to run from the top down. When it built, it's going to be line 1 to the ending line, which is in our case line 48. But in other languages like Python, you can actually use multiple processor core to be able to call various functions simultaneously. So if you're looking at like some kind of game, right, you know how some games are faster than other, typically using libraries and the type of programming languages to write that game, um, you can capitalize on like multi-core processor to be able to execute simultaneously. So your game is faster, right? Like the user can select character, right? And be able to select weapon at the same time. So it executes one core is, or two cores is going to handle that one function while the other two cores are handling the other function. So you can program it to do like that. A lot of your game development happens with C++ if you're using specific engine like Unreal, because certain engine uses certain programming languages. So if you are going that route, if you're thinking of developing games down the line, right, you have to, and when you download the engine to build your game, it comes with a lot of libraries. So it's going to be huge, and you would use specific IDE with it. But you know, you can use other engine as well. Unreal is typically used if you're using Oculus or a lot of the games. Like I know Meta or Facebook, they use Unreal quite a bit for Oculus. But if you look at other games, sometimes that it's written in Java, or even Python, right? Or other languages, web languages. Okay, any question regarding exercise 1? Okay, let's take a look at the next part. So you might have function that you don't care about return value. This is very, very common if you are using automated system, IoT devices. So for example, I might have a system that turns on my light when it gets dark, right? You see a lot of this. Or a thermostat when it reaches a certain degree. You can simply execute this in void. You see a lot of this in microcontrollers. Like if you play with Arduino, you see all void functions. So a function that there doesn't return a value, usually they use a keyword void in front of the function name, okay? So the compiler, when it sees the void in front of your function name, it knows that this function doesn't have a return value. So in this example, I have a function called void display welcome. And it simply would display a message, right? Welcome to the student portal, or welcome to my app, right? So it doesn't have any kind of return statement. So I can just simply use a void. So when you create a function and you don't need to return string or numbers, right? Text or numbers or characters, then you can simply create a void function. Declare that, right? And again, you can name it anything you want that implies the purpose of your function. And just like the other function, you would wrap it inside your curly brace for the body. Okay, so we're going to do a cout on this one. And then inside the main, we call the function. See how you call the function? You just bring down its name and put the parentheses next to it and end it with the semicolon. Okay, and then we do a return 0 at the end. So that shows you how you can use a void function. So we know that when you pass a value into a function like what we've seen, right? Like putting a variable inside its parameter, it does not change the effect of your original declaration in your variable. So if I have a variable called int x and x is 5, right? It doesn't have any kind of effect in the task of the function. So 5 is then going to be used because it's the original value. So your result would stay the same, right? It's just simply bring down that value straight through, and that's that. Now, if you're using an ampersand, right, next to your variable name, this is called a reference. So basically, it only reference that value and take that value and apply. I might have x is 5, right? And if I reference x and I take x and I multiply that by 2, then it changed my result. So 5 times 2 is going to give you 10. Okay? So if you don't use the ampersand, it just simply pass whatever the value into that parameter. But if you use the ampersand, it basically uses it as a reference variable and it changes the effect from the original value. So what this does inside the computer is when you use a reference variable, it references that memory address where that value stays, okay? And it would then use that memory address to look up the value and take that value and apply it for other tasks, other calculation. And you can do that for string, character, or any type that you want. Okay, so in the second example, we're gonna pass the argument as value. So I have a function called void modify, and I pass n inside the parameter. See you. Oh, not yet. Okay. Then I'm gonna take n. I'm gonna add it with 10. So you can use compound assignment for this, right? Now notice that there's no return statement because void doesn't return. Okay, you can use it to calculate things, but you don't return from it. If you do return, you declare other function with the type. And then inside the main, I want to say that x is 5. And I would call the function modify and I pass x. So the output at this point, it's going to say 5, even if I tell it to add 10, right? So it's going to straight pass the value into the parameter and it's going to output that value, which is 5. Now, if you compare that to the next example, where I, with my variable, I add the ampersand for n, right? And I would say x is 5, and I'm going to modify x. So it's going to take 5, and it's going to plus 10. So the output is going to be 15. Okay, that's the main difference is when you add the ampersand, there's an effect, right? So it's going to take 5 and it's going to plug that into this equation. It's going to take 5 and add 10 to it, and it's going to output 15. So it's changed. Okay, so that's the main difference between a reference variable and a regular variable that's passing value into your parameter for your function. Okay, so if you want the effect, you add the ampersand next to your variable name, and then so it would then calculate, right? Where if you don't want any kind of effect, any kind of calculation, you don't add that ampersand. Okay, then it won't change your value. Okay, so as we finish exercise 1, we're gonna proceed to exercise 2. If you miss it, we can come back to it at the end. So for 2, we're gonna write a program for a banking system. First, it's gonna simulate your deposit to preview a new balance. So let's say that I have $1,000 in my account. Let's assume I'm going to simulate that if I deposit another $1,000, it's then going to predict my balance as $2,000, right? And then I'm going to use, right, pass by value for the simulation. So I'm going to use the regular variable. Then I'm going to use a reference variable to do the real update. So instead of $1,000, I might deposit $500, right? Which gives me the real balance is $1,500. Okay, so you can do it this way to do prediction. It's used quite a bit for analytics purposes. So we can simulate that maybe we would deposit more money, but realistically, right, we would use a reference variable that we're going to deposit less. Okay. And you can do it for research purposes. You can do it for a lot of things, business decisions. So in this case, I want to show you how you can do this. And in this way, you can see how like AI would give you 2 options, right? 1, it's like this simulated, but 2, realistically, it would be like this, branch 2, right? So, so for exercise 2, we would start with include IOStream, like all the other program, and using namespace as TD. We first create a function. We're going to pass it by value. It doesn't change the original, like what we talked about. So I have a function called simulate deposit. You can call it anything you want. And in the parameter, I'm going to pass 2 variables. 1 is going to be the balance, which is the amount of money I start with. 2 is going to be the amount that I'm going to deposit. And then I'm going to take the balance and I'm going to take it, I'm going to add it to the deposit amount. And then I'm going to output, and I want to put simulation so you know, right? When you pass it as a variable, it doesn't change. So we're going to simulate it. If you deposit this amount, then your balance is going to be balance plus that amount, right? It's going to take the balance and add the deposit to it. So I'm going to see out, and you can keep it on all 1 line, but it's just going to be long. So I had it on 2 lines. And then make sure that you put the curly brace for your function. So when you pass it by the value, it doesn't change the original amount that the user input. Or if you initialize that with hardcode. Now I'm going to use the reference variable and pass it right? With an ampersand. Remember, you add the ampersand in the front, that's going to specify, right? That is a reference variable. We're going to pass it by reference. And this is the realistic actual update. And I put the comment there so you know the difference. So I have a second function called apply deposit. And inside the parameter, I'm going to use a reference variable for balance. So double ampersand balance, that's a reference variable. And my double amount stays the same because that's the deposit. And the calculation of it, I would take the balance and add it to the deposit amount. That's the same. And the C out is the same as the last function. We're gonna show the applied deposit and the amount for your balance, your updated balance. So in this case, we have two functions. One uses the pass by value approach, where there's no effect to the original. Second, we have a second function, and it would apply the changes by using the reference variable. And the main difference is that we have an ampersand in front of the balance variable in the parameter for the second function. So in this case, we use a function that doesn't return, right? So we use the keyword void. Can you write a return function? Yeah, you can actually for this particular scenario. That's really a choice, but I want to illustrate that you can use a non-return function and still be able to apply the values, pass by value or using reference. And so once you declare your function, what it's doing, then you have to set up your main on how it will call your function. That's the next part. So I'll scroll down a little because some of you probably got through that section. So main is the leader function. It's going to call the other two function that we declare, right? But we want to initialize value. So we have a beginning balance of $1,000. So we have a variable and we initialize that variable for the balance variable for $1,000. And we would have a second variable would be called deposit amount. Can you use a different variable name instead of balance compared to the previous? Sure, right? But in this case, we can use the same. So we want to start with $1,000 in our account, and we have a deposit amount. This one is different than the amount variable from your function, right? We just name it differently, but it would technically be the same thing. So the amount here is just a placeholder, and it's going to plug this in. And the next C out is just for aesthetics. So I put that this is a bank deposit example. We're going to compare, right, the simulation to the actual and see. We have a current balance that's going to show $1,000. So we'll bring down the balance for the C out on line 31. And we want to prompt the user to enter the amount of money that they want to deposit. So if I want to deposit $500, then it's going to plug that, it's going to store that value into deposit amount. which is the second variable inside the main function that we declared. Now, if you don't have the main, right, your program will not execute, like I said. It will throw error, it won't compile. So after your function, you have to work on the main function and how you want to call the function that you define. And then the last part of main, we're going to call the function that we had declared at the top. So you always want to declare your functions at the top, right? Your custom functions. I have seen projects for students that they declare the function after the main and it's confusing. So by practice, we should declare our function above the main and then use the main to call them. So because the compiler, it goes to that section to, again, put the function into memory. So it's just better that you declare it at the top. Can you do it at the bottom? Yeah, but that's not by practice for C++. And also Java. But Java, you have to put it in class. Uh, so for the simulation, we're going to call the first function, right? And then we're just going to pass the value, which is stored inside the variable balance and deposit amount, which is what the user input. So this is your function call on this line 36. And then you will have the next function call for the actual. So I hope that when you write these programs, right, by looking at the demonstration, you're able to grasp the concept. That's the point. And then you can create other programs on your own. Like you can make a grade calculator, you can do other things. And then we want to show the balance. So we want to do after simulation, this is the balance. Remember that it has no effect, so it doesn't apply. And then now we are going to pass by reference because we already used the reference variable from the above, right here. We're just going to simply pass balance and deposit amount just like the other function. And we call apply deposit function that we declared. And then right below it, you want to see out also to display the amount for your balance. So if you want to save more, right, you can simulate it where you can say, okay, if I deposit every month, if I deposit $500, right, how is that going to be for my account? Like how much can I grow in my account? And this can be for your saving or your checking. So the whole point is to show you how you can use the main to call the function at the bottom part here, right? And then the parameter when you do the call is exactly the same, but because you're using reference up here, it would have the effect for the apply deposit function. And then after you see out, just return 0. And make sure we do a curly brace closing for the main. Don't forget about that to avoid error. Any question? Did you miss something at the top? Would you like for me to scroll back up? I know some of you are writing the last part of the program. So if you have the complete program, build the program by clicking run, and then you can input the deposit that you want because you start with $1,000. So we hard code this in. You can also have, the user input in the beginning balance, but we initialized it at $1,000. And let's say if the bank requires it's at least $1,000 that you have in your account, right? That's the minimum amount. So we can keep it at $1,000. But in some cases, savings could be the minimum amount is you have to have at least, let's say $500 or $100. You can initialize a different amount there. If you miss something at the top, let me know. So I can continue with this and have it predict how much money I'm going to be able to save in a month or a year, right? Or if this is a weekly deposit or bi-weekly deposit, because if you get paid every 2 weekly, you can specify like how your direct deposit can go into your balance. So you can simulate it, or you can have the actual prediction, or the actual amount based on, and then you can subtract your expense, kind of like the program that we did previously. And so we can have a clearer picture on how much money that we would have in our bank account after we subtract the expense. So if you're looking at this program, it's only a portion of a finance program, right? A personal finance program. So in an app, you have many different components for the user. So you can write the function for the subcomponent and be able to execute it as a whole by combining these functions together. And that's really a modular approach. So you would have different modules, right, to be able to put together to have a bigger program. As you notice, as you move along in this class, as you progress, your program gets a little longer, right? And it gets a little longer. So by the time you take data structure class 17C, your program will be a bit longer. And I hope to take you through pointer and maybe end it before class because I'll save some stuff for 17A. They'll go over class objects. And then 17C, in the future classes, if you continue with the C++, yeah, you will have to know how to write your classes. And finishing, so I would recommend you take 17A and 17C to attempt Java because, you know, even if you don't, you can take the class and successfully complete, but it's a lot easier understanding classes from C++ and transition to Java because Java begins with class. I teach 18A online in the winter, so I go through a simple program to start and kind of like what you see here, but in Java language. And that's different from JavaScript. So if you want to take the class, you can sign up for it for the winter. I also do Python in the winter. Any question? Okay, so run and screenshot the program once you successfully complete the program. So in this, you would see how, and you can test it to see the simulate amount. Is it different than the actual balance, right? That's the goal, is to show you the difference. There's no effect and there's effect in the two different functions. A lot of students struggle with reference variable, and when we work on pointer variable, right? So you have to understand the difference, because if you are a programmer, or if you're gonna be a software engineer, right, you have to understand how you would approach to solve the problem. And we can implement these components in our functions to be able to use it effectively. That's the goal. Okay, 2 down, right? 2 more to go. Let me check on the time. I think we might go over 4 a little bit, but the next 2. So 2 has the most example. So we're going to talk about function overloading next, if you don't have any question for exercise 2. So function overloading is in every programming language. It is a way that we can use multiple function with the same, that shares the same parameter, right? Or sometimes the parameter could be different. So this can help you reuse the same function name over and over again. Like we can use it for calculation, we can use it for conversion of values. Like, you know how you use the app to convert money to different nations' money, like US dollars converted to pesos, right? Or Canadian dollars, or euros, right? So you would see that it's overloading the function. You can also use it for printing. You see that with printers. Okay, so the example that you see here, I use the same one that we previously used. So we are going to add the 2 value in A and B. So we're going to have a sum, a total of that, right? But notice that the first time I'm using int for whole number. Then to overload the function in the second time, we're still adding A and B, but you change up the type to double. right? Maybe the value in A and B got bigger, like in the millions. And then we total that up. And then we'll overload it again. And then this third time, we're going to introduce a third variable, C. So we're going to add one more variable, and that's also integer. So when you're overloading the function, you cannot reuse the same type over again. So the second time, it has to be a different type, like from int to double. And if you're using the type again, the third time, integer, right? It's the same as the first time. You have to add a third parameter. It will not let you overload if it's exactly the same. Okay? That's the technique. And then in this main, we simply cout, right? And we can initialize the value by putting them in the parameter itself. So A becomes 5, B becomes 10, right? That's going to be for the int type for the first round here. We're going to total A and B up. So it's going to take 5 plus 10. It's going to give you 15. The second time for the doubles, right, we're going to plug in 2.5 and we're going to add it to 3.7. It's going to output. And then the third round for overloading, you're going to take 5 plus 10 plus 15, which gives us 30. Okay, and that's how you overload a function. Okay, notice that they're not exactly the same in the parameter, otherwise you're going to get an error. Okay. So for 3, we're going to write a program that overloads a function, and we're going to prompt the user to enter a price. And we're going to take that price and we're going to subtract $20 from it. So we're going to give them a flat discount. Okay. And we're going to use this, we're going to overload the function again, but we're going to calculate the 15% discount from the price. And you would see the difference in whether should I apply the 15% discount or should I apply the flat discount, right? So in the business environment, they would calculate whichever discount that would use the most profit, right? Sometimes the 15% is less of a discount for the customer, so they would be able to profit more by giving the customer 15% versus the flat discount, like $2 off, $20 off. Okay, so let's take a look at the program. Okay, I begin my program with include IO stream as usual and using namespace as TD. I only have one function called calculate discount, but we are going to modify the parameter, overload the function with different parameter. Okay, that's the goal. So overloading simply is a way that we can change up the parameter for the same function that we had declared. So I have a double calculate discount. And I'm going to use this function to first calculate a flat discount. So we're going to pass the price, which is double price, and double flat discount. This is for the $20 off. I'm going to return price, subtract flat discount. So if my price is $50, it's going to subtract the $20, which gives me $30. So the customer only going to pay 30 bucks. And it's simply that for this function, right, we take the price, subtract the flat discount. And this is a returning function, so you have to type it. It's not a void. We're going to overload the function for the percentage discount. Again, the same function name. But in this case, we're going to double the price And so one of your parameter has to be different, right? So I have int percent. I'm going to return price, subtract price times the percent divided by 100. So the concept is that when you are overloading the function, it is the same function, but your parameter is different throughout each round, right? It could be one part of your parameter or all parts of your parameter. It could be different type or different variable. So in your main, you would then declare your price variable, and we would prompt the user to enter the price and store it inside the price variable. And then we would display, so we do a cout flat discount of $20 applied. And we call the function pass the price, which is what the user input, and $20 because it's going to subtract the $20, the flat $20. Then the second cout, we're going to display this percentage discount. So percentage discount of 15% applied. And we're going to call the function again for the calculate discount, pass the price, and pass 15 for the percent. Because it's going to plug that into here and divide it by 100 after it multiplied the price. We're going to do a return 0 and the curly brace to close out. So you would see the difference in if we subtract the $20, is the flat discount gonna give the customer less to pay, right? Are they paying less or more with the percentage or the flat discount? Now depends, right? In most business, they tell you you have to spend $100 or more to get a percentage discount or a flat discount. You might get $20 off if you spend $100 or a certain percentage discount. So you can do the comparison. So when you test this program, just make sure that you put the price higher than 20, so to see the difference, like $100. So in this exercise, you are learning how to overload the function. Again, we're using the same function name, the same function, right? We're simply modifying the parameter throughout the program. That's called overloading a function. And you can use it for different things, not just for a business application like this, right? We're going to do an overloading to calculate the volume shortly on the next one. But I hope that you are able to see how this exercise is different than the prior, right? In the prior, we're using different functions to calculate different things. In this one, we're using the same function, we're just changing up its parameter, and that's for overloading purposes. So if you have to solve a problem where you want to compare results, right, by executing the same task, then you can overload your function. We'll do one more after this, and then we'll do attendance. Or maybe I should pause the video, take attendance, and we'll do one more. I know some of you have to leave at 4 for other class maybe. Any question? So I go over the same concept with my Java and Python class. You're gonna see some similarity, right? Overloading function is the technique that's in all programming languages, right? Just know that you are using different parameter inside the same function over and over again. You cannot have the same parts of your parameter throughout. It will not like that. So when you overload, if you're using one variable that's the same, the other variable that you're passing, or you can also put in values, the actual value you see with 20, right, or 15. It's just depending on how you write it. So they have to be different throughout. Otherwise, the compiler it will complain, it won't like it. Okay. So you can change up data type, you can change up your variables inside the parameter. You can also use the same variable, but you have to change up the rest. You can add more variable. It cannot be exactly the same throughout when you overload. Okay, that's the idea. Okay, so let's do attendance. So I'm gonna pause the video real quick. We're gonna work on the last one. Okay, did anybody have any question on number 3? See ya.
See you.
Okay, you too. Okay, so test the program, screenshot it for your assignment submission. Don't forget that after number 4, you need to answer or describe what you have learned in the session. So since we all learn how to do volume, probably from high school, grade school, or if you're taking physics, you probably have to apply some of the volume information into your equation. We're gonna do that for number 4, okay? So in number 4, you are going to overload your function. Your function is named volume. And you are gonna calculate a cube. Then you're gonna overload it again to do a volume for a rectangular box. And you are going to overload it again. So you're using the same function name, right? Volume. You're gonna calculate a cylinder volume, right? Pretty easy. And I gave you the formula here, right? And so once we're done, we're just gonna do a screenshot of your program. Let me see if I have it. Okay. So we're gonna do a volume calculator. So we're gonna declare, or we're gonna write three pieces of the function, right? We already know that we have to use volume as a function name. Now in this one, you have to use CMath for the exponent part of your equation. Okay, so don't forget to include CMath for the exponent. See you later. Thank you, you too. Take care.
You too.
So I include IOStream and then include CMath for the power function. It's your exponent. And you are going to have using namespace std at the top. The first round, we're going to have the function and we're going to calculate the cube. So you're going to do double volume and double side. Okay, so the function is called volume and your side for your cube is going to be passed as a parameter. We're going to return and we're going to take, because it's cube, right? We're going to use the power function and we're going to pass the side and we're going to cube it. So we're going to raise it to the third power. So you want to pass the 3 there. So volume is side cube, right? So side, raise it to the third power. Once we're done with that, we're going to close out that curly brace for that calculation of a cube. Then we're going to calculate the volume for the rectangular box. And for a rectangular volume, you're going to take length times width times height. So we're going to do a double volume. We're going to use the same function name. But in this one, we're overloading by using 3 variables: length, width, and height. And we're going to return length times width times height for our volume. Easy. Make sure we close out the body of our function. Then for the third round, we're using the same function again, right? And in this one, we are going to pass the radius as a double type, the height as a double type, and the bool is cylinder. So because you are going to take the radius, right, you are going to multiply that also by pi. So we have to declare what pi is. You can take the radius and multiply with pi, but the radius, you're going to raise it to the second power, right? So we're going to use the power function there. So we're going to return pi times radius squared multiplied by height. So you should ask me, why do you have a bool cylinder here? Because in the second round, we passed 3 parameters. Okay, we want to continue that with 3 parameters. It will not like it if you only have 2 in the parameter, because in your equation, you only have radius and height. So you want to be able to pass the third parameter there. Okay. Since pi is a constant value, you want to declare that as a constant here. And then in your main, we are going to declare our variables: side, length, width, height, and radius, because those are also used in the function. And in this case, we're using the same variable names, right? We're not changing up the variable. You can, right? In the last few exercises, I showed you that you can use other variable in this function as placeholder for the variable inside your main. But in this case, we're going to use the same variable. You can. Then we want to show that we're making a volume calculator. And we want to display what the volume of a cube is. So at the end, you want to call the function because it's going to return the value for you. I hope I'm not going too fast. I'll slow down. So just like the last program, we're overloading the function, but in this case, 3 times. Each time we're gonna have the result for the volume for the shape. The first shape was the cube. So we would return the value that would represent the volume for your cube. After the prompt for the cube, enter the side of the cube. I will have the cin and I would put that onto the side variable. So when the user enter, like let's say the side of the cube is 5 inches or 5 centimeter, I would type in 5 and it would take that and it would cube it. So it would, so here is where we call the volume function and we would pass side. So it would take 5 inches and then it would raise it to the third power. So I would have 5 times 5 times 5, which gives me what? 25 times 5, 125 inches or centimeter. So you can call it with the C out like this. We saw that in the prior exercises as well, right? And then you have the rectangular box. You want to prompt the user to enter the length, the width, and the height. And we would have it recorded into the variable length, width, and height. And then your C out, you would say volume of rectangular box. And again, you're going to call volume function, but you want to pass length, width, and height in that call. So don't forget, after exercise 4, briefly describe what you have learned about functions today, right? We talked about returning from a function, non-returning function using void function. We also talk about pass by value by just using the variable inside the parameter. We also talked about using reference variable to be able to use pass by reference, right? There's a side effect for that. And then lastly, we're working on overloading the function, and you learn how to use different parameters in the same function and calling that same function continuously. And then for the next part, we're gonna see out volume for the box. And again, we call volume function. And then in the parameter, we have length, width, and height, which was recorded as an input from the user in the previous line. And so it would take whatever they put in for length, for example, 5 inches, and the width could be 3 inches, and the height could be 2 inches. So we would take 5 times 3 times 2, which gives you 30 inches or centimeter. And we would have the cubic units, right? Centimeter cube. So you know that. And then you repeat the same thing for the cylinder, right? You would have C out, enter the radius and height of the cylinder. And we would have the Cn for the radius and height. So you don't have to have multiple Cn. You can see that we can use continue with the arrows, right? And then have it recorded for the next variables, because each input is going to go to each variable already. So the radius, I can enter, let's say 6 inches. And then the height, I can enter 20 inches. So for the volume, we would then see out volume of the cylinder. And again, we're going to call the volume function, and we would pass radius, height. And you want to say for the third parameter, because it's a bool, right? B-O-O-L, a bool type. So we want to say that's true. Remember, we have to use a third parameter because the prior overload has 3 parameter. When you continue, you have to have the third one. So true. Now, if you want to only have 2, then you have to move this right after the other one. So this one has 1. You can have 2 and 3. So you can have different number of parameters when you're overloading. You can have the same number of parameters, but just make sure they're different, like different variable or different type. And then lastly, we would have return 0 and closing curly brace. And that wraps up our program. So now if you want to flesh out this program, let's say I want to be able to take the volume and ask the user to input weight or apply weight to it, so that way I can calculate maybe for shipping purposes, or maybe storage purposes, like in the physical storage. If I need to be able to load it onto trucks or a train or plane to transport it, etc. So there's more that you can do to this. But the point is to show you how you can overload functions. It's fun. You can think of ways to overload it, right? Yeah, programming can be fun. But you can see this being applied for, like, if you are recalculating the same, using the same function for the calculation, but you want to have different values or different input. And this is a returning function. So as you see, we use the return keyword, right, for each of the volume that you're calculating. But again, everything is then called inside the main. And we would then do C in and C out in main. You can have C in and C out in the individual function. You just gotta make sure that it is then being applied. So if you have C in, C out in the function, you normally would initialize the value, or apply it in a different way inside your main. So everybody approach it a little different. So now when you hear people say overloading function, you know what that means. Okay. Java does the same thing, so you can use the same concept for other languages. So if I want to calculate the volume of a sphere, right, then I can just continue with the same function. So you can go with all kinds of shape, a cone. Yeah, yeah. CMAX, CMAX. Yeah. The third one? I'll flip to that one real quick for you. Yeah, because you can't pass the other variable in it. It has to be. Yeah, so the flat discount, you subtract the flat discount beneath it, and then you have to say int percent. So change the double flat discount to, there's two. One is gonna be the flat discount where you subtract the $20. And then the second one is where you calculate the percentage. You see the difference? Yeah, if you're using double flat discount, then you subtract the price. You subtract the flat discount from the price. And then, yeah, you had skipped one. And then the second piece is you calculate the percentage discount, where you would take the price, subtract the actual amount of the discount. So price times percent divided by 100. And in the parameter, it's in percent. Okay. You see the difference now?
Yeah.
One function is for flat discount and so you overloading it, it's the same function. You run it the first round for the flat discount, the second time you overload it for the percentage discount. Okay, so if you are running into errors, check your section of your functions, or it could also mean look at your error message, your error code information on your message, and then you can go to. So I'll put back number 4. Right? Okay. If we're finished, have a wonderful day, and I'll see you Thursday. We'll work on a few more things on Thursday about functions. So, and I will be available virtually today for office hours, but I forgot to post that again. But if you need help or anything, email me, let me know. Right? I'll update your grades tonight. Okay, let me stop.